Hi folks, today we're gonna see the concept of recursive functions, which is prevalent in any programming language, and see its implementation specifically in C language. So let's start. This is an example code which I've written. So this explains the basic concept of what recursion actually is. Here we have a main function and you have some lines of code. So the compiler starts with the main function, it executes some lines of code, and then it encounters the recursion call, which is the function call to a function called as recursion. And as we had seen in our previous video, that the control is then passed on to the recursion function where it is declared. So the control goes to the recursion function, and there it executes some lines of code, and compiler sees that there's another recursion function. This is another call to the same function within the same body of the function. This may sound kind of complex, but let's see how it unravels. Just to brush up theory a bit, recursion is when a function calls itself. You can see recursion is the function and it is calling itself inside the body of the function. This concept of recursion is quite similar to loop. So you can see recursion calls this function recursion, this recursion again calls the function. So there's a looping kind activity going on over here. So is this nothing but an infinite loop? Let us see. When does the function stop calling itself? This also leads us to the two important parts of every recursive function. The first one is the base case, where the solution to the simpler arguments can be given directly. And the next one is the recursive case. It is where there is an actual function body that increments and decrements so that the arguments can slowly approach towards the base case and finally end their recursion over there and return the final answer to the main or any other function. Enough of theory. Hop onto your favorite IDE and let's start coding. If you're currently working with us, you can download this file from the link in the description below. So let's start on with a small example. Here, this is a small function which helps us print a Fibonacci sequence for a specific position. Fibonacci sequence is basically where the number is gonna be the sum of the two previous numbers. This can be solved using normal loops like for loop, while loop and do while loop, but this can be solved out using recursion too. So we're gonna do that today. In this, I have declared a function prototype which has a returning type of long int, and the name of the function is fib or fib, which takes in one parameter which is an integer. So let's start declaring this function. As we had seen in the theory, there are two important things in every recursion statement. The first one is the base case and the second one being the recursive case. Both of them are very important and complement each other and help in making a function recursive. In the base case, we are gonna set up a condition. So every recursive function has a condition within itself, one for the base and the other one for the recursive case. So in this if, I'm gonna write because there's an integer n, if that n is equal to 1 or it is equal to 0. This is the base case we said, because we know that Fibonacci sequence always begin with a 0 and 1. So if it is any of these two numbers, then we must return the number itself. So we can return n. Now when it comes to the recursive case, we will have to use an else statement over here, which will be executed if the number is not any one of these numbers. So this marks the end of our recursive statement. In this, I'm gonna return basically the Fibonacci number which is generated when the argument is n minus 1, and I'm gonna add this with the number which is generated after Fibonacci of n minus 2 is calculated. So this is basically my calculation of adding the previous two numbers which is done in the Fibonacci sequence. I'm gonna indent this. Now in the main function, I'll first declare an integer n and then a simple printf and scanf in order to take a number from the user. So I'm gonna write inside the printf, enter a number, and I'm gonna scan that number using a %d specifier as it is an integer, put it inside n. Finally, I'm gonna print the Fibonacci of that number. Since it is returning a long integer, I'll have to use the LD specifier, which stands for long decimal, which is basically a long integer. And I'm gonna mark the numbers for these specifiers. The first one is gonna be n, and the second one is gonna be the Fibonacci of n. So this is just how simple it is, and we are done with our coding part, and let's see if it executes. I'm gonna compile and run this now. So here it asks for a number, so I give 4. Okay, the Fibonacci number at the position 4 is 3. In this image here you can see the fourth Fibonacci number is 3. Now let us try for another number. I'm gonna execute this again. Now I'm gonna type a bigger number, let's say 9, and it returns the Fibonacci number at the position 9 is 34. Recursion can be quite beneficial at some times, and it may solve problems which may be very difficult to solve using the normal loops, but recursion has its own disadvantages, which can be a topic for the next video. If you found this video helpful, you could promote this video by hitting the like button and subscribing to our channel, and lastly sharing it with your friends so that they can get their concepts clarified. Thank you.